Okay guys, for section 3.4 I picked one of the word problems. When you get to this section, there's basically four main types of equations we're going to be solving. And so I didn't want to just pick an equation problem because there's different types, and depending on what you need, you might need help with something different. So if there's a problem that stands out that you need help with, let me know so that I can help you with that. But otherwise, I'm just going to do one of these word problems. So it says the formula here models the population of a U.S. state in millions T years after 2000. So the first question is, what was the population of the state in 2000? Okay, so for the year 2000, let me write down this formula. So a key thing here is that T is the number of years after 2000. So if we're asking about the year 2000 specifically, that means T equals 0. Okay, T equals 0 for the year 2000. So that's pretty easy. We just plug that in. Now, if this is times 0, that makes the exponent 0. E to the 0 power is 1 because anything to the 0 power is 1. So we essentially end up with 18.5 times 1, or just 18.5. So in the year 2000, it's 18.5 million. And you'll notice when you do these problems, if they're in this kind of format, this number is always your kind of starting amount or initial amount, just because of the way plugging in 0 makes this part go away. But the harder part to this question is this part. The population of the state will reach 26.6 million in the year blank, and it wants us to round to the nearest year. So this is kind of different than what we were doing in 3.1. 3.1, they would give us a year and we'd figure out the population. Now they've given us that population, 26.6 million, and they're asking us to solve for T, to solve for the year. Now, these kinds of problems could be about just about anything. They're all going to work similarly when we're solving for something in the exponent. First, we have to get the exponential piece by itself, which means we're going to divide by the 18.5. If it's 18.5 times E, then I need to divide by 18.5. Let me pull up this calculator. Oops. Typed the wrong thing. 26.6 divided by 18.5. Alright, hold on. Let me pull up the better calculator. Okay. So the reason I wanted to pull up the better calculator is because I want to show you how I work with this when it's these long decimals. The biggest thing you want to remember is you cannot just chop off all these decimals. You can't just make it 1.4. To save time, we're going to write down, maybe we'll write down 1.4. But what I'm typing in my calculator later needs to have all these decimals. So I'll show you what I mean when we get to it. So I'm not going to clear that. I don't delete that. I leave it in my calculator till I'm done solving. Okay, so now that we have the exponential piece by itself, I like to take the natural log of both sides. Okay, and the reason I do that is on the left side we'll have the natural log of this decimal. And on this side, since the natural logarithm and the exponential base here are inverses, you're essentially left with just what's in the exponent. That is from a property we learned in 3.2. Okay, we had a property in 3.2 that told us this was equal to x, okay, because the bases match. So it's the same idea, it's just equal to whatever's in our exponent. So our last step is to get t by itself, we're going to divide by this decimal here. Now, when I type this in, I'm not going to type in 1.4. I need all these decimals. If you chop it off, you're going to lose accuracy, and then your final answer will be a little bit off from what it's supposed to be. So I'll show you how I do that. If I need the natural log of this decimal that I just had, I hit second, and answer is right here. That pulls up the previous answer, whatever is right before it. So the natural log of my previous answer divided by 0.1731. That way I didn't have to chop off any decimals. I didn't lose any accuracy, but I also didn't have to sit here and type out this whole thing, right? So it makes it better. So that tells me it is t equals 2.098 years, but they want us to round to the nearest year, so that would be 2002. 2 years after the year 2000. So I want you to see what would happen if we had tried to chop off the decimals, okay? If we had just typed 1.4. See how different these answers are, right? You lose accuracy as you chop things up. So the answer is 2002. Okay? Hope that helps. If you have any more questions about the calculator and different little tricks like that, let me know. I can help you with that. But otherwise, I think that's it for this video.